Today's lesson is about congruent triangles and their corresponding parts. So in your notes we talked about congruent figures, so we're just going to focus on triangles just because there's less sides than focusing on like an octagon or something like that. So let's go ahead and start. So the first thing we want to do is use what's called our congruency statement. A congruency statement is just being able to match up congruent angles. It's all about a pattern. When you're naming congruent figures, you name them by their congruent corresponding angle measures. S is listed first and P is listed first. That means that angle S is congruent to angle P. And here's the thing. Some of you don't like to use highlighters. That is perfectly fine. However, you need to do something to ensure that you know the difference between all the congruent pairs. You don't have to use color, but you do need to use something. Whether or not you put like a circle around S and P or a square, something. So then I'm going to move to my next set of letters. My second letter is G and Q. Angle G is congruent to angle Q. They're both listed second, so that lets me know that they are both the same. And lastly, we have R and D. So angle R is congruent to angle D. Next is to kind of go through and list our congruent sides. If you actually draw on your picture, you should be able to know the congruent sides. So I'm going to look between yellow, green is SG. So segment, oh my gosh, I wrote a Q. Okay, let's kind of go over here. Segment SG is congruent to PQ. Yellow, green, yellow, green. Okay. Then I'm going to move over to green, blue. So segment GR is congruent to QD. Green to blue, green to blue. And lastly, I'm going to go yellow, blue. So segment SR is congruent to yellow, blue, PD. Okay. You can also use the congruency statement to help you with this. So I'm going to rewrite it down here so it's a little bit bigger. So SGR is congruent to triangle PQD. When you're working with the segments, you can also find the congruent segments names inside of the congruency statement. So if you notice, SG is first to SG, PQ first to. SG is congruent to PQ, SG, PQ. Now you can do that with all of the segments. It just gets a little confusing because your segment names are actually going to overlap. So we have GR, QD. GR is congruent to QD. And again, the same thing with SR and PD. So if we're looking again at our picture, S is first, R is last, P is first, D is last. SR goes to PD. So it's a little more confusing if you're using the actual congruency statement. However, it's really just preference. You draw on your picture, or you can go ahead and just use the statement. So this is used to actually solve algebraic questions. So this is in the figure, we've got triangle LNN congruent to QRS. And I went ahead and, of course, I chopped off the instructions. So our goal here is to solve for X, and we want to solve for Y. Before I start, I know that you all are great mathematicians, and you're so good at just thinking that you know everything, which is awesome at times, but when you have these kinds of problems, it is so easy to make a mistake and get the wrong answer, especially on the state test. They're going to put a ton of extra info to hope to trick you. If you take the time to mark on your picture, you will not make silly mistakes. So just stop for a second before you start. Make sure that you know how the picture is turned. Get your bearings straight so you understand how to set the problem up. So L and Q are congruent, so L corresponds to Q. This takes no time at all to do, so I expect you to do it. N and R, M, R. And then we have N and S. N, S, and S. Take the time. You don't have to use highlighter, but you need to do something. It's such an easy concept that you're going to get overconfident and just make a silly mistake. Take the time to label. So now I'm just going to kind of focus. Find my variables. So I have a variable at LM, and it's 2x plus 11, so that's yellow, green, yellow, green. 2x plus 11 has to be the same as 3x minus 9. So LM is congruent to segment QR. I'm going to go ahead and just solve. 2x plus 11 equals 3x minus 9. I'm going to get those x's. I'm going to subtract 2x to the other side using subtraction POE. Bring down my 11. 3 minus 2 is 1, so I'm just going to leave it as x minus 9. Add the 9 to the other side. 11 plus 9 is 20. So my x value is 20. Next, I'm going to go ahead and solve for my y value here. I'm going to switch pens so it doesn't get all confusing. So I find my next variable, y plus 10 at m, and I know that m and r are congruent. So angle m is congruent to angle r. And then I'm going to go ahead and solve. Angle m is y plus 10, and that's going to equal 2y minus 40. Take the time to draw on your picture. It's an easy concept to mess up because we get overconfident and just assume that we know everything. It's okay to label your picture. I encourage you to label your picture for a reason. So now that I've labeled, I know for sure that m and r are congruent angles. So I'm going to move my y by subtraction. 2y minus y is just y minus 40. Add my 40, 10 plus 40 is 50, and that is my y value. Remember, this congruency statement is not just haphazardly thrown together. It's named based on the congruent angles in each triangle. You need to draw on your picture. That's why it's there. I didn't waste ink printing it for you to ignore it. So use your picture to help you. Once you know what's equal, then it's basically just you setting stuff equal to each other.